Hi everyone, in today's video we're going to be talking about how we can find the instantaneous rate of a change of a function using algebra. So we've moved on from talking about average rate of change and we're going to be focusing on finding that instantaneous rate of change. So really this is going to kind of be a summary of what we talked about in class and really getting to that algebraic piece of how we find this instantaneous rate of change. So the new vocabulary we had was instantaneous rate of change of a function, which we're also now calling the derivative. And so the big idea here is that the instantaneous rate of change of a function is the slope of a function at one point. Okay, and another name for that instantaneous rate of change is the derivative. Now, we have a note here that instantaneous rate of change, or what we're calling the derivative, gives us the slope of the tangent line. Okay, now when we're using notation for derivatives, the most common notation you'll see are probably these three. So we can call the derivative f prime of x. You might see the notation dy dx or y prime. And so as we go through, I'll probably be using all of those different notations so we get used to how they look. Now, we're going to be focusing on how do we find that instantaneous rate of change or the slope of the function at one point. So for right now, we're really looking at how can I use limits in algebra to find the slope at a particular point. And we're going to have two ways of doing that. Option one is going to be to use this formula. So we could say that our derivative, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And the idea here when we calculate it, which we'll do in a minute, is we would take the particular value of x that we were given in the problem and we would replace x here and here with that value and then do our algebra. And like I said, we'll actually work through some problems of that in just a couple minutes. Our second option for finding the derivative, again using limits, is to use this formula, which is the limit as x approaches a of f of x minus f of a all over x minus a. And so similarly here with this option, we would be finding that derivative if at a particular value of x. Actually, this probably should have said f prime of a, really. So we would be taking that value and substituting it everywhere we had a. So this should really be f prime of a, which a would be just a constant where we're trying to find that derivative. So let me just rewrite this so we've got it clean here. F prime of a, and that would be this value we would be using here. Sorry about that. All right, now the nice thing here is we're going to have this algebraic process, but we also have a way of checking answers on our calculator. So if we were to go to our calculator, let's see if I can fit this here. If you were to hit the math key, so your first move, you're going to use the math key. And then we would choose option 8 here. If you see that says n deriv. So that's going to help us calculate a derivative. So we would select 8, and under it I'm just going to put that n deriv that you see on the screen there. And you'll see when we hit, oops, I didn't hit 8. 8, there we go. We get our derivative notation, which looks like this on your screen. So you can see it said d over d, and then there's a little box to fill in here. Then there's parentheses and another box. And then a few more spaces here. So here's how this would work. When we're typing it into our calculator, we're always going to put the variable x here. And then in this box, we would type in our function. So whatever f of x is equal to. When we type x here, this gets populated with x, and then this would be, we'd type in the value where we're trying to find the derivative. So the value of x at which we are calculating the derivative. So let's just take an example. Let's say our function was f of x equals x squared, and we were being asked to find f prime of 4. So when we went into our calculator, the notation would look like this. It'd be d dx, we would type in our x here. In parentheses, we would type in f of x, which is x squared. In here, we would have x equals, and then we would type in 4, which would come from this value. So that's how we would translate this problem into our calculator, and then our calculator would actually be able to evaluate that derivative. So what we're going to do on the next page is practice with each of these different options for calculating the derivative, and then we're going to use our calculator to check that our answer is correct. Okay. So let's flip over here. So our first problem here, it says f of x equals 3x plus 7, and our job is to find f prime of 2. And we need to find that derivative in 2 different ways. So let's look at option 1. So I'm going to write my general formula here. My limit definition said that it's a limit as h approaches 0 of f of x plus h minus f of x all over h. So in this case, since I'm finding f prime of 2, that means I'm going to substitute that in everywhere I have an x. So in order to find f prime of 2, I'm going to find the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So let's see what we need to do with that. I'm going to kind of leave my limit notation up here, and I'm going to work with my function down here. So now f of 2 plus h means I look at my formula for f of x, and everywhere I see x, I'm going to replace it with 2 plus h. So now I'm going to have 3 times 2 plus h plus 7, and I'm going to make a little note for myself there. This really is just f of 2 plus h. Right? I did this piece here. F of 2 plus h, I just substituted 2 plus h everywhere I had x. Now I'm going to subtract f of 2. Well, f of 2, if I substitute 2 for x, 3 times 2 is 6, plus 7 is 13. And that's going to be all over h. So again, if we're keeping track here, this 13 was just f of 2. Now we can simplify this. So if I distribute, 3 times 2 is 6, plus 3 times h is 3h, plus 7 minus 13 all over h. The nice thing here is my 6 plus 7 is 13, minus 13 is 0, so those cancel. And I get 3h over h, which is just equal to 3. So now my limit is just the limit as h approaches 0 of 3. Since I'm taking the limit of a constant, that is just 3. So it's telling me that f prime of 2 is equal to 3. All right, let's look at option 2. Option 2, our formula looked like this. So the limit is x approaches a of f of x minus f of a all over x minus a. Again, since we're evaluating where x is 2, that's my a value in this formula. So I'm going to substitute 2 for a. So now f prime of 2 is equal to f of x minus f of 2 all over x minus 2. Oops, and actually I should have here, this is actually equal to the limit as x approaches 2. Sorry for squeezing that in. We have to have that limit notation for it to be equal to the derivative. So again, let's take this and simplify it. F of x is just 3x plus 7 minus f of 2, well if I plug in again, 3 times 2 is 6 plus 7 is 13. And I've got all over x minus 2. So now if I simplify my numerator, I have 3x. 7 minus 13 is minus 6 over x minus 2. Now I notice that I can factor a 3 out of my numerator. And those x minus 2's cancel. So again, now I have this equal to the limit as x approaches 2 of 3, and so that value is just 3. So my limit calculations tell me that the value of the derivative is 3. So now I'm going to go ahead and check on my calculator. So again, I'm just going to go through the steps again. We have math. I'm going to select 8, and it's going to give me this notation. So now I'm going to select x. My function here is 3x plus 7. And I'm evaluating when x equals 2. And so we can see that the value that we got for our limit is correct. So I think at this point what we'll do the second example, number 2, together in class, so you can have a chance to ask questions about anything that wasn't clear, and then you'll have time to practice with a bunch of different examples in class. All right, thanks for watching, and I'll see you back in class.